In the metal finishing, we discuss about technological importance, and one of the technique used in metal finishing process, that is electroplating process, in which we discuss about principle governing the electroplating process, and another one is in a theory of electroplating process. So first, coming to the metal finishing. The metal finishing, it is defined as it is a process of deposition of a metal on the surface of another metal. It is called as metal finishing. Whatever the process involved in the deposition of a one metal on the surface of another metal, that type of process called as metal finishing, in which once any metal subjected for metal finishing process, there is some technological importance of the metal finishing process is observed. These are the some technological importance. One is that metal get a good decorative appearance, or it improves the corrosion resistance, or improves the heat resistance, or surface hardness, or it gives a good thermal conductivity, good electrical conductivity, thermal reflectivity, optical reflectivity, etc. See, these are the some technological importance of the metal finishing process observed when a metal it is subjected for metal finishing process. In which in the metal finishing process there are two techniques are used to deposit a one metal on the surface of another metal. One is electroplating and another one is electroless plating process. In which, coming to the first one, electroplating process. Electroplating, it is a process of deposition of a metal on the surface of another metal by electrolysis. It is called as an electroplating process. So these type of process, whatever the process involved in the deposition of a one metal on the surface of another metal by using an electrolysis process, means in the presence of anode, cathode and an electroplating bath solution with the help of electric current, whatever the deposition of a metal takes place on the surface of another metal, that process called as an electroplating process. In this electroplating process, there are four major components are used to deposit a metal on the surface of another metal. One is an anode, another one is a cathode, another one is an electroplating bath solution, and another one is DC power supply or battery. These are the four major components used in electroplating process to deposit a metal on the surface of another metal. In which, coming to the reactions observed, so at the anode oxidation reaction it takes place, in which sometimes we are using in a metals as an anode, sometimes we are using inert material as an anode. In which, whenever we are using metal as an anode, in which there is oxidation reaction it takes place, means whatever the metal is present undergo oxidation gives metal ion with the liberation of electrons. Suppose we will use inert electrode as an anode, in which there is a liberation of oxygen with electrons takes place. So these are the two anode reaction observed in electroplating process. Coming to the cathode reaction, so at the cathode there is a deposition of metal takes place due to the reduction reaction of metal ions present in electrolyte solution. So this is about theory of electroplating process, in which in this electroplating process, whatever the deposition of metal it takes place on the surface of another metal, it mainly depends on three principles. There are three principles which governing the electroplating process. One is in a polarization, another one is in a decomposition potential, and another one is in a overvoltage. See, these are the three principles which governing the electroplating process. So in which in the last class we discussed about first two principles. One is in a polarization, another one is in a decomposition potential. In which, coming to the first one, polarization. The polarization, it is an electrode phenomena and it is determined by Nernst equation, that is E is equal to E0 plus 0.0591 divided by N log concentration of metal ion. In which the polarization, it is defined as polarization, it is a variation in the electrode potential due to slow supply of ions from bulk of the solution to the electrode surface called as polarization. Whatever the change in potential observed in the electroplating process, sometimes due to the slow supply of ions from electrolyte solution to the electrode surface. So on that time, there is a change in potential, it takes place. That change in potential called as a polarization. For example, so generally in the electroplating process, the deposition of the metal takes place by using an electrolytic cell. So now consider the electrolytic cell, it is under operation, means it is under working, in which once electrical energy or current it is applied to the electrolytic cell, generally metal ions are created at the anode, that metal ions are consumed at the cathode, there is a deposition of the metal takes place on the surface of cathode metal, in which sometimes whatever the metal ions are created, that metal ions are stored or accumulated at the anodic surface only. See this diagram. This is an anode electrode and this is a cathode electrode, in which whatever the electrons, metal ions created at the anode, it is stored at the anodic surface only due to the some factors like one is nature of electrode or electrolyte concentration or temperature or rate of stirring of electrolyte or product formed at the electrode. Due to these type of factors, sometimes the electrometal ions are accumulated or stored at the anodic surface only. Once it is stored at the anodic surface, decreases the concentration of the metal ion at the cathode. So on that time, the electrodes are called as a polarized. So these type of process called as a polarization. So these polarization, it is observed in the electroplating process sometime due to these types of factor. One is in a nature of electrode, another one is an electrolyte concentration, temperature, rate of stirring of electrolyte, product formed at the electrode. Is it clear for you? First one, polarization. Any doubt in this polarization? So this is first one principle which governing the electroplating process, that is polarization. First one. Can anyone tell me what is polarization? What is polarization? What is polarization? Polarization, it is defined as variation in the electrode potential due to slow supply of ions from bulk of the solution to the electrode surface. So after this polarization, coming to the next, another one factor which affects the principle which governing the electroplating process, that is decomposition potential. So the decomposition potential, it is defined as it is the minimum external potential required to continuous electrolysis of an electrolyte, called as a decomposition potential. Means how much amount of electricity or electrical energy or current required to deposit in one metal on the surface of another metal, that much amount of electrical energy, it is called as a decomposition potential. So this decomposition potential, it is determined by using an electrolytic cell. See, this is one electrolytic cell. See, in this electrolytic cell, it consists of two platinum electrode. This is one platinum, this is another one platinum electrode. Both the platinum electrode, it is immersed in an acid or base solution, in which once initially at lower the voltage, there is no reaction, it takes place because that voltage is not enough for the reaction. Therefore, once the voltage of the cell, it is increased up to 1.7 volts slowly. Once the voltage is increased up to 1.7 volt, there is a evolution of hydrogen and oxygen takes place on the surface of the smooth platinum electrodes. In this anode electrode, there is an oxygen is evaluated, cathode there is a hydrogen, it is evaluated. So these evaluation of oxygen and hydrogen, it indicates the electrolysis of an acid or base solution on the surface of smooth platinum electrodes. Therefore, the required 1.7 volts of electrical energy, it is called as a decomposition potential of an acid or base solution. Is it clear? This is the second, another one, that is a decomposition potential. Any doubt in this decomposition potential, you can ask now. So these are the two principles which governing the electroplating process. So what we discussed in the last class. So after this decomposition potential, coming to the next, another one principle which governing the electroplating process, that is overvoltage. So next one is overvoltage. Any doubt in the decomposition potential, or in this you can ask now? Polarization. So next one is overvoltage. So the overvoltage, it is defined as sometimes in the electroplating process, while depositing a metal on the surface of the another metal, compared to a theoretical decomposition potential, there is a more amount of electrical energy is required. So in which whatever the excess voltage or excess current required to deposit a metal on the surface of another metal greater than theoretical decomposition potential, it is called as an overvoltage. Therefore, the overvoltage, it is defined as it is the excess voltage applied above the theoretical decomposition potential, above the theoretical decomposition potential, theoretical decomposition potential, theoretical decomposition potential, it is called as an overvoltage. Whatever the excess voltage applied above the theoretical decomposition potential for a continuous electrolysis of an electrolyte, that excess voltage, it is called as an overvoltage. And this overvoltage, it is mathematically expressed, that is eta is equal to experimental decomposition potential minus theoretical decomposition potential. See, this is the formula which is used to express the overvoltage. Overvoltage, it is by using symbol eta. Eta is equal to experimental decomposition potential minus theoretical decomposition potential. In which, coming to the one example for this overvoltage, for example, see, whatever the decomposition potential for an acid or base solution, for example, theoretical decomposition potential for acid or base solution, that is 1.3 volts. But in the experiment, the experimental decomposition potential for same acid or base solution, it requires up to 1.7 volts. So in which the difference between these two, that is 0.4 volts, it is called as an overvoltage of acid or base solution. Overvoltage of acid or base solution on the surface of the smooth platinum electrodes. So this is next another one principle which governing the electroplating process, that is overvoltage. So in which, coming to the some factor which affect the overvoltage. So here also, due to some factor only, sometime there is a more amount of electrical energy it is required. See, these are the some factors. See now number 1 is in a nature of the electrode. So whatever the electrode having in a rough surface, and another one is in a nature of the product formed on the electrode, current density, temperature, rate of stirring of the solution. These are the some factors which affect the rate of over voltage. Because of these types of factor, sometimes in the electroplating process, compared to theoretical decomposition potential, there is a more amount of electrical energy required to continuous electrolysis of an electrolyte. That excess amount of electrical energy required, it is called as an overvoltage. It's a clear. Next, another one principle governing the electroplating process. Any doubt in this, you can ask now. Either in the polarization or in the decomposition potential or in the overvoltage. They will ask any two principles for 6 marks. Explain the following principles governing the electroplating process. Number 1, polarization. Number 2, decomposition potential. Number 3, overvoltage. In these three, any two they will ask. If they will ask polarization, you need to write down definition. That is variation in the electrode potential due to slow supply of ions from bulk of the solution to the electrode surface. Then explanation with factors affecting polarization. These three things you need to write down for polarization. If they will ask decomposition potential, you need to write down first definition, that is minimum external potential required for continuous electrolysis of an electrolyte. Then you need to write down electrolytic cell diagram with explanation. If they will ask over voltage, you need to write down the excess voltage applied above the theoretical decomposition potential for continuous electrolysis of an electrolyte. Then this formula you need to write down, that is eta is equal to experimental decomposition potential minus theoretical decomposition potential. Then one example, a theoretical decomposition potential of acid or base solution on smooth platinum electrodes is 1.3 volts. But when we conducted experiment, it consumed up to 1.7 volts. Therefore, the different 0.4 volts called as an overvoltage of smooth acid or base solution on the surface of smooth platinum electrodes. In which, coming to the factors affecting overvoltage, one is the nature of electrode, nature of product formed at the electrode, current density, temperature, rate of stirring of electrolyte. Is it clear for you? Principles governing the electroplating process. Got it, all of you? Okay. So after this overvoltage, coming to the next topic, that is electroplating process. So generally in the case of electroplating process, there is a one metal, it is deposited on the surface of the another metal, in which whatever the another metal or article we are going to use to deposit a metal on the surface of the another metal, that metal surface, it should be free from the impurities. Because if any other impurities are present on the surface of the another metal or on the surface of the article or substrate, and that time when we will deposit a metal on the surface of that metal, it gives a bad deposit. Instead of giving a good or even or uniform deposit, it gives a bad deposit, or metal cannot deposit it properly on the surface of that metal if that metal surface containing impurities. Therefore, in the case of electroplating process, the first step is surface preparation or pre-treatment. After subjecting metal surface for surface preparation or pre-treatment step, then only in the electroplating process metal subjected for electroplating. Therefore, in the electroplating process, the first step is surface preparation or pre-treatment. that is surface preparation or pre-treatment process. So in the case of surface preparation or pre-treatment process, whatever the impurities present on the surface of the article or substrate, it is removed. In which to remove the impurities present in the surface of the substrate, there are three steps in the surface preparation. First one is removal of organic impurities, removal of organic substances or organic impurities, first one. Second, another one step is removal of inorganic substances or inorganic impurities. Next one is rinse with distilled water or demineralized water. See, these are the three steps involved in the surface preparation process or pre-treatment process, in which first one is removal of organic substances. So in this step, we are going to remove the organic impurities present in the surface of the substrate. Second one is removal of inorganic substances. In this step, we are going to remove the whatever the inorganic impurities present in the surface of the substrate. Next one is rinse with distilled water, in which coming to the first one, the removal of organic impurities. In the case of removal of organic impurities, there are two types. One is by using a solvent cleaning method. First one is solvent cleaning method, either by using solvent cleaning method or by using an alkali cleaning method. There is a removal of inorganic impurities takes place on the surface of the metal or on the surface of the substrate or article. So in which coming to the first one, solvent cleaning method. See, in the case of solvent cleaning method, by using some organic substances, like one is either by using a toluene, or chlorobenzene, or by using another one is benzene, or by using an organic solvent like acetone, etc. There is a removal of impurities present in surface of the metal, it takes place. So these type of technique called as a solvent cleaning. In the case of solvent cleaning, the organic impurities present in the surface of the substrate is removed by using organic solvents like toluene, chlorobenzene, benzene, acetone, etc. Coming to the second, another one method, that is alkali cleaning method. So in the case of alkali cleaning method, these impurities are removed by using some alkali solutions like one is a sodium hydroxide, another one is a sodium carbonate, sodium bicarbonate, etc. By using these type of alkali solution, there is a removal of organic impurities takes place on the surface of the metal. So these type of technique called as an alkali cleaning method. So this is first step in surface preparation, that is removal of organic substances by using solvent cleaning and alkali cleaning method. First one. So after removing the organic substances, the metal surface subjected for removal of inorganic substances. So in the case of removal of inorganic substances also, there are two types. First one is mechanical cleaning method. Second, another one is treatment process. Acid treatment. See, these are the two steps which is involved in the removal of inorganic substance. One is a mechanical cleaning, another one is an acid treatment or pickling process. In which, coming to the first one, mechanical cleaning process. In the case of mechanical cleaning process, the oxide or rust particle present in the surface of the metal is removed by using simple hand cleaning methods, like either by using a sandpaper, sandpaper, or by using some mechanical brush, or by using some other mechanical tools. Whatever the inorganic impurities like rust particles, dust particle present in the surface of the metal is removed. So these type of technique called as mechanical cleaning. Coming to the next another one, that is an acid treatment process. So in the case of acid treatment process, the dust or rust particle present in the surface of the metal is removed by treating metal surface with dilute acid solutions, like either by using a dilute H2SO4 or by using a dilute HCl solution or by using a dilute HNO3 solution, etc. These type of technique called as an acid treatment process or pickling process. After this removal of inorganic substances, metal surface is rinsed with distilled water. After rinsed with distilled water, then the metal surface subjected for electroplating process under the conditions. So this is about next another one topic in electroplating process, that is electroplate surface preparation or pre-treatment. See, we have one example in your syllabus for electroplating process, that is electroplating of chromium. So in that, before writing electroplating of chromium conditions, you need to write down the surface preparation. It carries 1 marks. So in which you need to write down like this: before the electroplating, metal surface or article subjected for surface preparation, in which removal of organic substances by using solvent cleaning and alkali cleaning methods, and removal of inorganic substances by using mechanical cleaning and pickling or acid treatment process, finally rinse with distilled water. Then metal surface subjected for surface preparation under the conditions. Then you need to write down conditions. Therefore, you need to remember this surface preparation. There are 3 steps. One is removal of organic substances. Another one is removal of inorganic substances. Another one is rinse with distilled water. In which, coming to the first one, removal of organic substances, there are 2 methods are used. One is solvent cleaning, another one is alkali cleaning. In which, in the solvent cleaning, the organic substances are used to remove the impurities either by using toluene or chlorobenzene or benzene or acetone. The impurities are removed. Coming to alkali cleaning, in which by using alkali solutions like sodium hydroxide, sodium carbonate, sodium bicarbonate, etc., the impurities are removed. This is first one, removal of organic impurities. Coming to the second one, removal of inorganic impurities, there are 2 types. Either by using mechanical cleaning or acid treatment, the impurities are removed. In which, coming to the mechanical cleaning, so here the inorganic impurities like oxide or dust particle or rust particles removed by hand cleaning methods, like by using sandpaper or by using mechanical brush or by using some other mechanical tools, there is a removal of impurities takes place. Coming to the next one, acid treatment. So in the acid treatment, the impurities are removed by treating metal surface with dilute acids like either by using dilute sulfuric acid or dilute hydrochloric acid or dilute nitric acid, etc. So after removing inorganic impurities, finally metal surface rinsed with distilled water, then subjected for electroplating process. Is it clear for you? Any doubt in this surface preparation, you can ask now. Artha aita? Because this is very important. You need to remember surface preparation. You have one example for electroplating, that is electroplating of chromium. In that hard chromium, and another one is decorative chromium. While writing that compulsory, that you will get for 7 marks without 5. While writing that, you need to write down the surface preparation. Can anyone tell me the steps involved in the surface preparation? Which is the first step in the surface preparation?
Removal of organic substances.
Removal of organic substances. Second step.
Removal of inorganic
substances. Next one.
Rinse with distilled water.
So, can anyone tell me the steps used to remove the organic impurities? Steps used to remove the organic impurities. Methods used to remove the organic impurities. First one, solvent cleaning.
Alkali cleaning.
Second one, alkali cleaning. Same as methods used to remove the inorganic impurities.
Mechanical cleaning, acid treatment.
Acid treatment or acid cleaning or pickling. Is it clear for you? Overvoltage and surface preparation.
Yes, sir.
So one instruction to you, you have a first internal test on 28, 29, 30, not on 21, 22, 23. It is postponed 1 week. That is this month 28, 29, 30, you have a first internal test. For this first internal test, you have a syllabus for 2 models, complete 2 models in all the subjects. Not only one subject, in all the subject, you have 2 models. So that now only you start to read for your first internal test. Is it clear?
Sir, it is online.
How much marks?
Through online only for 50 marks. Each model you will get 25 marks question.
Okay, sir.
50 marks only. Whatever the marks you scored in this 50, it is reduced to 30. Then we will add 10 marks of assignment and quiz. We will give 40 marks IA. Like your first semester average of 3 internal tests we are going to take. Not any best of 2 or average. Okay. All 3 internal tests, it is compulsory for you. Suppose you will absent for 1 internal test. If absent only, your marks will be 0. Therefore, don't absent for internal test. Now only you start to read, and some students still not submitted assignment 1. You need to submit in time, and already assigned assignment 2. That is only corrosion 5 question is there. That you need to read, you need to write, and you need to submit through Teams. So maybe this week I am going to give this metal finishing assignment also, and in which whatever the assignment question is there, that are very important question for IAS. So you read well. Clear? Any issues in that?
No, sir.